next speaker is in the person of Riya Joshi. Riya is a data scientist at Microsoft, and she's also a career advisor for women in data science. Today, Riya will be giving us a talk on the topic holistic evaluation of large language models from references to human judgment. Please let us welcome Riya on stage.
Hello, everyone. Thank you for joining this session. Let me quickly share my screen and we can get started. Okay, so hi, everyone. Today we are going to talk about holistic evaluation of large language models, which have been a very hot topic of research as well as an industry level topic for quite some time now. About me, my name is Riya Joshi. I work as a data scientist at Microsoft and I live in Washington, USA on the West Coast. Feel free to connect with me over LinkedIn. Here is my QR code. Before starting, thanks a lot for coming here, taking this time out. I really appreciate a lot. I hope that you get to learn something and, I can be of any help. So let's talk about today's agenda. We're going to talk about LLM evaluation, but we are going to answer few questions about LLM evaluation while understanding this. First is, what is LLM evaluation? Why do we even want to evaluate LLMs? What are some of the challenges that we face while evaluating LLMs? And then how do we even do that? Especially how industry is doing that, how research is doing that. We're going to talk about that. So what is LLM evaluation? So assessing the performance and effectiveness of LLMs as well as LLM systems is what constitute as evaluating LLMs. We don't only want to solve a task or evaluate a task being solved by LLM, but we want to evaluate it through multiple angles. Basically, if it's what is the effectiveness, what is the how accurate it is solving it, and what is how fair the LLM is while dealing with the whole task. So LLM evaluation more or less is very multidimensional. We evaluate multiple aspects of the task being solved. Here are few of the metrics that we're going to talk about, which come up very frequently when we talk about LLM evaluation. Please know these are just this is not a holistic list, but just a subset of the few metrics. This will differ from task to task, or from pipeline to pipeline, or from the custom solution you're trying to build using LLMs. But just to give you a brief overview and idea, let's discuss some of these metrics. First is accuracy. How correctly the model generates the response based on an input. That is what accuracy is. Then comes relevance. How relevant the answer is in response to the query. Then comes fluency. Now, all these language models are trained to mimic the human language. So they need to sound like, human. They need to sound like they're making sense. So that's why how well they're able to mimic the human language is also an important aspect, and that comes under fluency. Then it's also very important that they are not just speaking any gibberish and just making logical sense, and there is consistency, like there is in most of the human languages or most of the, what we talk. So that is what called coherence. Then comes bias and fairness, which I feel is one of the most important measurement metric. It means that model's response is free from societal bias or harmful content. Now, all these models have been trained on a huge corpus of open source data, which have a lot of bias as a society has. And sometimes these models can hallucinate, that is, make up information that doesn't even exist, or spew harmful content. Now, we really don't want that, especially given the impact of these large language models in past few years. This is one of the important metrics that we always want to check. Then comes task-based metrics. Now, it can differ from, task to task. For example, if we are building a RAG pipeline where we are retrieving some of the documents and then generating answers on top of those documents, then there are multiple components. There's a retriever, then there's a generator component, and we want to evaluate both of these components separately. If you do not understand anything about RAG, that's totally okay. That was just an example and totally not required for this presentation. But why? Why we want to, what's the fuss about? Why do we even want to evaluate LLMs? Now, in past 3 years or something, LLMs have become omnipresent. Now every layman, even people who are not associated with AI, know about LLMs, know about ChatGPT. They have been integrated in a lot of business use cases, health-related use cases, even consumer products. So they are widespread, they're everywhere. And now, because of this great power, comes great responsibility. If we do not measure, or we do not measure the impact of these LLMs as well as the outputs that they are generating, it can cause havoc if they are, misguided. So that's why we want robust evaluation mechanisms to firstly ensure that they are, whatever tasks that they are assigned to do, they're doing that correctly, as in the quality assurance. They are generating output accurately, and the output is relevant and coherent. Then comes ethical insurance, which we already talked about a little bit, which again, it's very, very important because these models have been trained on huge corpus of data. They sometimes pick up those biases or pick up those harmful contents or just, go rogue. And that's what we really don't want, especially where these LLM models, are used and can impact people. For example, loan applications. If some loan applications are just rejected because of gender or race or something else, just because of some biases in data or biases in the society that already exist, right? We do, or some chatbots spewing out racist comments. We don't want that. So that's why ethical assurance is very, very important. And that's a very important aspect of all our evaluation metrics as well. Then comes performance monitoring. If you have deployed your LLM solution in production, you would want to track the performance of LLM systems over time to ensure that they are meeting standards. But there are some unique challenges, especially when it comes to LLMs. So, how LLMs work, they generate text by predicting the next word. And this prediction is probabilistic in nature. As in, for same input, the output can be different every time. And because of this non-deterministic nature, LLMs are even harder to evaluate. But then, how do we evaluate LLMs? So right now in industry, there are and research, there are two main ways of evaluating LLMs, and we're going to discuss both of them, and which one is preferred over other. So yeah, let's get started. First is reference-based evaluation, where we have ground truth references, where we have the correct answer with us. And then is reference-less evaluation, where we do not have the ground truth references, so we do not have the correct answer. Now, in reference-based, you pass an input to an LLM, it generates an output, and then we have a yardstick against which we measure this output. We know what the correct answer is. Okay, we know what the correct summary is, or we would know what the correct, maybe classification is, whatever. Similar to what it is in supervised learning, right? We know the correct answer. So we compare how similar or how dissimilar the output is with the actual label. And that's how we evaluate. So that's reference-based evaluation. Then comes reference-less evaluation. And here is where you can say magic or uniqueness lies. That here is where people are trying different things, and different research is happening. Now, here we do not have correct answer. Then how do we evaluate? How do we even know that whatever output the LLM has generated, is it good enough? Here, there are multiple ways of doing it, how they do it, but major component is they use an LLM to generate an output, giving an input, and one LLM generated an output. Then they go and ask another LLM, usually a little bit, bigger LLM or powerful LLM, to compare that, okay, this is the input I gave to this LLM, this is the output. Does it make sense? Are they similar? Are they in sync? Something like that. In prompts, there can be multiple ways of doing it, or they can even do a double check, basically pass the same input twice rather than once, just to be sure, if it's making sense and it's not hallucinating. So these are multiple ways, but the common theme is they use another LLM to evaluate the output generated by one LLM. Now the thing is, Yeah, reference-based makes more sense. We have, grounded truth, but the thing is, it is very difficult to have this much labeled data. Labeled data has always been problem, especially now with LLMs which need a huge amount of data and they're being used more and more in solving more and more problems. Labeled data remains a big problem. So that's why a lot of the research and a lot of things are being done in reference-based evaluation. Nevertheless, we'll discuss both methods. Let's start with reference-based evaluation. As we have already talked about, they have already the correct answer. They have the golden labels. Let's talk about the three major ways which people are doing for reference-based evaluation. For example, if you already have the correct answer, then how will you evaluate? One is statistical methods. These methods have been used in NLP for quite some time now. So they measure the lexical overlap or word overlap or n-gram overlap between the generated text and the reference. Okay, so there is no semantic understanding here. It's syntactical matching, lexical matching, basically word or n-gram overlap. They are just checking if these many words are present in generated task, are they present in reference text or not. So because of this limited capabilities, they do not perform that well when evaluating very complex, output from LLM. So they have not been proven to be that good evaluation strategy, especially in case of LLMs. But if you want to learn more, there are some which you might have known, or if you want to read more, there are links in the references. View score, Rauch scores are some of them which are the statistical methods. Then comes non-LLM based models or methods. Here, what happens is um, statistical methods only take syntax in picture. Here we used pre-trained transformer based model, for example, BERT, and create embeddings of both of these reference and ground truth text generated and reference text, and then see what is the overlap or what is the similarity, cosine similarity between them. If they are similar or if they are representing similar things, their embeddings will have a higher cosine similarity. Okay, so that's how we measure. Instead of just checking the word overlap, we check the semantic similarity between them. Okay, they are decent, better than statistical methods, but still not as great. Then comes third, LLM as a judge, which we just briefly discussed a little bit before in our reference-less solutions. Same thing, even if you have a reference, you can work. You can, ask another powerful LLM that, okay, this is my output generated by this LLM, and this is actual output. How similar are they? Okay, give me a score. You can write prompts like this. Give me a score. Tell me if this matches or not, things like that. You can use the same strategy of LLM as a judge, even in case of reference-based solutions. Now let's talk about reference-less evaluations, which we briefly discussed. Here I'm going to talk about a very particular framework, which has become state-of-the-art recently. Okay, so which is called G-Eval. Okay, it uses LLM as a judge, and what it does is, let's talk about. So here, if you see this chart, it uses a user prompt that basically tells you, for example, this initial user prompt, what task it needs to evaluate and what is the evaluation criteria. For example, here it says that you will be given a summary and you need to evaluate how good that summary is. And you need to evaluate it on a criteria which they're calling coherence. Okay? There can be different criteria. It can be relevance, it can be accuracy, whatever. Okay? So it gives the task of evaluation, what it needs to evaluate, and then an evaluation criteria. Then this prompt is passed through an LLM. Now this LLM call generates a step-by-step process, which they call evaluation step, which they do it using chain of thought, okay, which is a way of prompting your LLM to think step by step, especially in reasoning or logical tasks. Okay, so here what it does is this first LLM call generates an evaluation step or basically step-by-step plan of how it's going to do this evaluation. Okay. Now, why this happens, why this works is because it's been proven that, when you give a chain of thoughts or, step-by-step instructions to LLM of thinking, in reasoning thinking tasks, they tend to work better. So that's why they first generate this evaluation. Now, in the second LLM call, they might be using same LLM or different LLMs that can be, totally on your design. Then what they do is they pass these evaluation steps and the input context as well as the target text. For example, here our target text is summary, which we want to evaluate. Okay. Now, with all this information of all the text and the evaluation step of how to do it and what to do it, it finally generates a score. For example, here it will be generating a coherence score because that's what our evaluation criteria is. So that is one way of using LLM to evaluate the outputs of your another generated LLM. I hope this makes a little bit sense. Now let's see. Okay, so this is just a comparison metric of different metrics and what are the different models. For example, you'll see Rauj 1-2L, which is basically statistical methods. They are not doing that well. Then non-LLM based models are decent, but not that well. And the state of the art is GEVAL, which is a LLM as a judge model. Okay, they are known to be closest to human evaluation. Okay, now reference-based evaluation are more reliable, but less common because of less labeled data, as we already discussed. LLM as judge are closest to human evaluation right now, okay, when evaluating LLMs. So they are the best methods right now that we have to evaluate LLMs when compared to all of them. But they still suffer from the non-determinism issue of LLMs, right? That we already discussed, that because they are probabilistic in nature, they are more or less reliable, and LLM calls can be costly. So if you're already using, LLM to generate an output and also LLM to evaluate, it can bump up your cost. But this is the best solution and the more workable solution that we have for LLM evaluation. These are few of the references that I have gathered while researching for this talk. And if you're interested, go through them. And I hope you enjoyed this session. Thanks a lot. Thanks a lot for attending. Please connect with me. Let me know if you have any questions. And thank you. You have been a great audience.
A very, very big thank you to Ria for sharing your insights with us on the topic holistic evaluation of large language models from references to human judgment. Your expertise and passion on this topic is truly inspiring. Thank you so much.